Okay, the next thing we're going to look at is multiplying rational expressions. And this process is going to be very similar to what we did when we just multiplied fractions. So remember from before, if we have a fraction a over b times c over d, we just multiply across the numerators and get a times c over b times d. But also remember, when multiplying fractions like 6 over 7 times 14 over 18, we don't just multiply across in practice. So what we normally do is first look for any common factors that can be reduced and then multiply the simpler problem. So let's look at, if I have 6 over 7 times 14 over 18, let's write this out as 14 2 times 7, and 18, let's write that as 3 times 6. And now we can see some common factors. I have a 6 in the numerator and denominator, and a 7 in the numerator and denominator, and that leaves me with 2/3. Where if we followed the rule exactly and just multiplied across, I don't know about you, but I'm going to need to pick up the calculator to get that 6 times 14 is 84, and 7 times 18 is 126. And then we know that that is not in lowest terms because both of those numbers are even. So we know that they're at least divisible by 2. So from here, we would have to go through the process of figuring out common factors and get this to reduce. And of course, once we figured out what the factors were, we know that the answer is 2/3 from the way we worked it the first time. But you see that the second method is just harder and more time consuming. So we're going to use basically that same idea when we're multiplying rational expressions. First, we want to completely factor each numerator and denominator. And then we can cancel any like factors. And that's, of course, as long as 1 is in the numerator and 1 in the denominator, because anything over itself is 1. So we want 1 in the top and 1 in the bottom to be able to cancel. Alright? So let's look at this first example. First, we want to make sure each piece, each numerator, each denominator of each fraction is completely factored. So if we look at this first one, I have x squared minus 25. We know that that is a difference of squares. So I can write that as x minus 5, x plus 5. And in the denominator, x squared minus 16 is also a difference of squares. So I can write that x minus 4, x plus 4. And then luckily the second fraction, everything is already in lowest terms. So now we can go through and cancel any like terms. So I see an x plus 5 and an x plus 5. And I see an x plus 4 and an x plus 4. And that's going to leave me in the numerator with an x minus 5 over an x minus 4. And this is my lowest terms reduced answer. That we cannot simplify the x's there, as we talked about on the first page, because that x minus 5, if you wanted to look at it, is one term, and x minus 4 is one term. So that is my lowest terms. Alright, so let's look at number 2. For this one, the first fraction, everything is in lowest terms. So we're just going to rewrite this one. But for the second fraction in the numerator, we have a common factor of 2. So I'm going to factor that as 2 times n minus 2. And then for that second one, the denominator, if you need to do scratch work, go over to the side. Don't do it in line with the problem. So this one is a trinomial with an a that is not equal to 1. So we would look at a times c is 3 times negative 1 is negative 3. So my options would be 1 times negative 3 or negative 1 times 3. And we're trying to get a b of negative 2. So we would want the 1 and negative 3. So then I rewrite 3n squared. We can say plus n minus 3n minus 1. And then if we pair them off, we have a common factor of n. And that leaves me with 3n plus 1. And then in the second pair, we have a common factor of negative 1. Leaves me with 3n plus 1. And then we factor out that common binomial. And now we can put that factorization back into the problem. We have 3n plus 1. Times n minus 1. And then we can start looking for any common factors that we can cancel. And this time I have a 3n plus 1 and a 3n plus 1. And then we can also cancel the 2's. So that's going to leave me in the numerator. The only thing that's left is n minus 2. And in the denominator, I have an n and an n minus 1. So that is our final reduced answer. Alright, for number 3, this one is a little more difficult because I think each one of these is going to need to be factored. But at least I see a lot of a's equal to 1, so that should help. So again, if you want to do scratch work, try to do it over on the side. So let's take the x squared minus x minus 6. This one we don't have to worry about AC because the a is 1, right? So we know c is negative 6, and we want b negative 1. So we have 1 times negative 6, negative 1 times 6. Let's see, we could have 2 times negative 3, negative 2 times 3. And if we want b equals negative 1, it's this one, right? So with this one, we don't have to go through that rewriting and grouping process because a was 1. We can use our factors directly, and this one will be x plus 2, x minus 3. So we can put that into the problem. And then the denominator, that's just 2 terms. So we have a GCF of x, so we can factor that out. That leaves me with x plus 2. And then in the numerator of the second fraction, we only have 2 terms again. And I do see a cube, but this is not a perfect cube because x squared is not a perfect cube. So all we're doing here is factoring a GCF of x squared. And that leaves me with x plus 1. And then for the denominator, we have x squared minus 2x minus 3. So C is negative 3 and B is negative 2. So we have 1 times negative 3 or negative 1 times 3. So it's going to be this one. So we have x plus 1 and x minus 3 that we can put back into the problem. X plus 1, x minus 3. And then we can start looking for any common factors that we can cancel. So I see an x plus 2 and an x plus 2. I see an x minus 3 and an x minus 3. And I see an x plus 1 and an x plus 1. And that would leave me with x squared over x, which if you remember back to your exponent rules, if we have like bases being divided, we can subtract the exponents. So the final answer to this is just x. Alright. Last type of this is to look at dividing rational fractions, and it's going to be very similar to the